Welcome. Today I will cover some of the ELT, or Extract, Load, Transform capabilities, also known as pushdown optimization, that were added for Google BigQuery in SnapLogic's November 2021 release. Google BigQuery is a fully managed serverless data warehouse that enables scalable analysis over petabytes of data. It is a platform as a service that supports querying using ANSI SQL. We are seeing enterprises continue to embrace the cloud data warehouse as a key piece of their modern data stack. Along with this technology adoption, enterprises are embracing the Extract, Load, Transform, or ELT design pattern, which allows them to replicate data in their CDW in as timely a manner as possible. SnapLogic's ELT allows teams to democratize data across their organization regardless of coding abilities. Using the ELT, users can leverage the SnapLogic UI to visually design pipelines that execute SQL in one of the supported data warehouses. In addition to Google BigQuery, SnapLogic also has ELT support for Snowflake, Redshift, Azure Synapse, and Databricks. In this demo, I will demonstrate how you can use the SnapLogic platform to load Salesforce data into Google BigQuery and visually design SQL logic that will execute in BigQuery to build models of aggregated data. In this case, we will be generating a model that shows the total number and total revenue of opportunities won by sales managers in the last month and the last quarter. Here, I have a pipeline labeled Orchestration. This pipeline will execute two separate pipelines I have created. The first pipeline will load Salesforce data into BigQuery, handling the extract and load portion of the workflow. Then once that process is completed, it will trigger the second pipeline that contains my transformation logic. Opening this pipeline, you can see I am replicating the opportunities, accounts, users, and user roles data. The only change I am making to the data is adding an SL sync timestamp that can later be used to orchestrate incremental loads and CDC. Next, stepping into the transformation pipeline, you will see some of the ELT snaps. The first step of building a model is choosing what data will be needed. In this case, I will be using the ELT select snap to pull data from the opportunities and users tables. You can see in the select snap we have suggestion capabilities that allow you to browse the databases and tables the account has access to. You also have the option to write an SQL query in addition to using the UI. You will also notice a preview checkbox on every snap. We give users the option to selectively preview data on a snap-by-snap basis to conserve cost when building and debugging ELT pipelines. Looking at the preview data, we show you a sample set of data as well as the resulting SQL query. Note, you can change the number of rows for preview data in user settings. I then use the transformation snap to only pass the columns I need for my model, and then use the filter snap to only return one opportunities. Using the transformation snap, you can also flatten nested data and convert columns to the appropriate data types. Here, I am converting the close date column from a string to a date, so I can filter based on relative dates in the next snap. I have used the copy snap to create two outputs I can use to aggregate data based on my 30 and 90-day windows. Looking at the 30-day aggregation, you can see I am using some SQL to filter data where the close date falls within the last 30 days. I then use the aggregate snap to generate two new columns, one for the total revenue and the other for the total number of opportunities closed in the past 30 days. Here, you can see suggestion support that returns a list of aggregate functions for the CDW. Note, in some cases, SnapLogic has added proprietary support for functions that CDWs do not support natively. For example, while Redshift doesn't natively support linear regression as an aggregate function, the option still appears in the SnapLogic UI for users to leverage. For these cases, the SQL to perform the requested operation, such as a linear regression, is generated by SnapLogic and appears in preview data. Back to the model we are building, you can see that I have also set the aggregate snap to group by owner ID. I then use join snaps to combine the columns of aggregated data into what will be a single table. Using the transformation and unique snaps, I filter out redundant columns and rows. Now that I have the data I want, I use the Merge Into Snap to write the data into a BigQuery table. You can see the resulting SQL needed to generate our model in the output preview of the Merge Into Snap. If I switch to the BigQuery console, I can query the table I merged data into and see the aggregate numbers for each sales manager or owner ID. Leveraging SnapLogic allows you to manipulate and aggregate data using both ETL and ELT methods. As I've shown today, SnapLogic allows you to automate the movement of data, but the platform can also be leveraged for enterprise automation. For example, this same data can be used to create a chatbot that sends an update whenever an opportunity is won. The combination of these features and more are what makes SnapLogic's all-encompassing solution so compelling to organizations looking to leverage data. Thank you for joining us today. We hope you have enjoyed this demo and look forward to hearing from you soon.